The development of atomic theory. Democritus came up with the particle theory model in roughly 300 BC. Saw nature as ceaseless motion of small, indivisible, and internal material particles of different shapes and sizes. Indivisible in Greek is atomus. The root of the word is atom. Cannot be created or destroyed. Define atoms as indivisible particles. Atom is the smallest particle of matter. Explains natural occurrences such as the existence of elements. Downside, not a scientific view of the atom, only a conceptual definition. Did not address subatomic particles, electrons, protons, neutrons. Antoine Lavoisier, 1780. He was also known as the father of modern chemistry. He stressed the importance of precise measurement, also came up with the law of conservation of mass. During his lifetime, he identified 33 elements. Dalton, solid sphere model, 1800. Atoms are solid, indestructible spheres. Explained chemical properties and how atoms combine to form molecules. Explains chemical changes. Confirms law of conservation of mass, law of definite proportion, and law of multiple proportion. Downsides. Does not include existence of nucleus. Does not explain ions or isotopes. Does not include subatomic particles, protons, neutrons, and electrons. Thomson, J.J. Thomson. Plum pudding model, 1904. Atoms must have a positive and negative part. Since electron mass was so small, the positive part of the atom must be larger. Further experimentation disproved this hypothesis. Downside, does not explain role of electron in bonding, does not include existence of neutrons. Robert Millikan, 1908. Oil drop experiment. This was able to calculate the exact mass and charge of an electron. Some new assumptions. Since atoms neutral, must also have a positive part. Rutherford, planetary model, 1910. Plum pudding model suggested an even distribution of positive and negative charge. That's wrong. Rutherford's gold foil experiment showed that the volume of an atom was mostly empty space. New assumption. Small, dense, positive charge nucleus, small, negative electron distributed in, large volume orbiting the nucleus like planets. Downside. Does not place electrons at specific energy levels. Does not include existence of Bohr, the Bohr model in 1913. Combined findings of Rutherford and others and presented the modern atomic model. New assumptions. Something else in the nucleus that adds mass and stability. Electrons only exist in specific energy levels, orbitals around nucleus. Downside, cannot be used to explain the shape of molecules, implied orbiting pattern around nucleus. 1926. The quantum mechanical model. Scientists who contributed include Schrödinger and Heisenberg. Current model of the atom, protons, plus, and neutrons, neutral in the nucleus. Electrons located in specific orbitals around nucleus. Orbital, a three-dimensional area where we are likely to find the electron. Cannot known exact location of the electron. Chadwick, 1935, the neutron discovered. It was not until 1935 that the existence of the neutron was finally proven. The mass of the neutron is about 0.1 times greater than that of the proton. The neutron does not have a charge. The neutron adds stability to the nucleus, minimizes repelling positive charge of protons.